Today we're going to look at the selection sort. Now, selection sort works by finding the smallest slash largest element and switching its place with the element in the first slash last place. The sort continues in this fashion until every element is in the right place. Now, I did that smallest, largest, first, last, depending on whether it's going to sort it in ascending or descending order. Also, some selection sorts work a little bit differently. Instead of putting the smallest in the front, it puts the largest in the back. Every different selection sort, how you implement it's going to be slightly different, but the concept is going to remain the same. So here we go. Here's how selection sort, the actual code, looks like. Again, we can look at slightly different variations to it. But what's going on is that in selection sort, we're going to traverse the whole array here. So notice going from 0 to the length. We find the smallest element. We're going to say, hey, the smallest is at index I. Then we're going to traverse the rest of the array, finding who is really the smallest. So we're going to compare index j to index smallest. If the value at index j is less than the value at index smallest, hey, we found a new smallest. We then are going to swap those elements. We then move to the next value, and we keep going until we've gone through the whole array. Now, big O notation, we use this to classify algorithms by how fast they are able to work based on any input size. So given a collection of size n, the selection sort for random order, best case, and worst case is the same, because regardless whether it's at random order, or it's already in order or nearly sorted, or it's in reverse order, it does the exact same thing every time. So looking back here, it doesn't matter. It's going to go from 0 to the array length. It's going to traverse all of the rest of it, looking for the smallest, and then it's going to swap it. Its performance is not impacted based on whether it's already sorted, reverse order, random, or it doesn't matter. So let's look at how a selection sort works on a random array. So we're going to traverse our array. We're going to look for the smallest element. So we're going to start the smallest element as index 0. All right, so let's compare these. Nope, index 0 is still smallest. Oh, index 2 is now smallest. Compare, compare. Oh, index 4 is the smallest. Oh, index 4 is still the smallest. So I end up swapping my first value with index 4. So this becomes a 1, this becomes a 4. Everything else stays the same. Now my largest now is going to be at index 1. And I'm going to go through again. We're going to try to find, what value is the smallest. So compare those. Oh, so value at index 2 is smaller. And we keep going. Oh, looks like value at index 2 is small, so it swaps those. So it's a 3 and 8 swap. Everything else stays the same. Now it looks for the next smallest. Well, the next smallest is here, so it's going to swap them. So those swap. Next smallest is 5. He's actually in the correct place already. He swaps with himself. Next smallest is 6. So there we go. The 6 and the 8 swap. Next smallest is 7, so that's 7 and 9 swap. The 9's in the correct place, but technically they swap. The 9's in the correct place. He doesn't actually swap, because by the time you've checked this position, the last position has to be correct, because at the worst case scenario, those two swap. And that's the idea of how selection sort works. And that's the end of this notes.